okay? Y is equal to 0. Well, that's just over here, right? We're supposed to go right on the axis there. Right, there's y is equal to 0, right? And this is the TY plane that we're doing it, right? Like I said, you have to get used to, it's not always x and y. And then y equals a over b. All I was looking for was just drawing a line over here. Y equals a over b, okay? And the only thing that you know is that it's a positive number, right? So that's all there is to it. Okay, so those are the equilibriums. Okay, let's go on to part B now. Sketch typical solution curves in the regions of the TY plane determined by the equilibrium solutions. And again, I think I said in class, I don't need a bunch of curves in every region, okay? All you need is one representative curve in each region. Okay, so let's start off now. How many regions are there, basically? There's the one above this equilibrium, there's one between these two equilibriums, and one below. Okay, let's start with the top one, okay? Now just look at this, y a minus by. When I'm in this region over here, let's say, let's take this one over here, okay? Again, just put a dot to start it. Clearly, y is greater than a over b, right? Here's the line y equals a over b, y is greater than a over b. And since b is positive, that says that by is greater than a, okay? Well, if y is positive, by is greater than a, isn't that quantity negative? It's a positive times a negative. So all I'm looking for is something like this, and it should asymptote to that. Okay, so that's one graph. Okay, now let's look at the point where y is between here and here. Okay, so now we have basically, so y is still positive, right? But now we have y is less than a over b. Right? Because it's right. Here's y equals a over b. Y is less than a over b. That says at my initial point, by is less than that. Well, now what happens? I've got a positive times a positive, right? I got a positive minus by is less than a, so that's positive. So therefore, it's always increasing, but we have to asymptote. We can't cross into the other region. And since we're always increasing left to right, we decrease going right to left, and I'm looking for something like that. Okay, so that's that one. And then finally, we have this region over here, right? And here we have a point where y is negative, right? Y is negative. So what happens? A negative times a positive is a negative, right? So therefore it decreases, which means that as we go over here, it increases, and again, can't asymptote. Okay? And the way the credit goes, it's 12 points in total, 3 for each curve, right? So 3 points for this guy, 3 points here, and 3 points here. Okay, so you may have seen that you lost credit, for example, if you had the slope wrong or if you crossed into another region, okay? But 12 points altogether for that. That's probably the bulk of the problem. And then part C asks you to tell, I remember something here also basically, is that it even says over here, right? Classify each equilibrium solution as asymptotically stable, unstable, or semi-stable. I saw people, I don't know, maybe in the book they had these tables with pluses and minuses all over the place. I don't know why it's so difficult. I mean, you just look at this. There are only two equilibriums to consider, right? Y equals 0 and y equals a over b. We go to y equals a over b, and we see as t increases, they're both approaching that number, a over b. So that's asymptotically, or if you just said stable, that was fine. Stable or asymptotically stable, right? Okay, and what happens over here now? Both solutions go away from the equilibrium, right? Here's the equilibrium, this one is going away, and that one's going away. So this equilibrium is unstable. Okay? Yeah. Okay, and how much was that? I guess the ring is 4 points. Okay? So again, to summarize, you get 4 points for just finding the equilibriums, y equals 0, y equals a over b. 3 for each of the curves in the 3 regions. That gives you 12. And then the 4 remaining points, just classifying them as stable or unstable. And again, you'll notice that I didn't penalize you twice, okay? For example, if you drew your graphs over here the wrong way, but your stability at least matched the graph, I gave you full credit for that, okay? On the other hand, though, if you made another mistake, if you drew it for example, like this, you know, this, which should be unstable, you said it was stable, then don't say, oh, I got the right answer though. Okay, I'm trying to see consistency over here, okay? And again, I'm trying to do the best where I don't want you to lose credit on part B because you got part A wrong, okay? It's the logical, you know, from the graph, I don't care if your graph is wrong so long as you've got the, you know, the right classification. Okay, any questions on that? Okay. So let's go on to problem number 2, okay? And again, I think people came here before the test and I kind of outlined what was going on, and there's one problem basically from each of the topics that we did, right? The first one is what? Autonomous systems. And then there's some people who did actually very well on most of the exam, and for some reason maybe didn't study or chose not to answer problem number 1. It's a shame, it's so easy. Okay, I remember there were a few people and I was kind of surprised to say, gee, that's, you know, probably the easiest example or problem in the whole test. Okay, problem number 2. Again, what was the second topic we did? I even put these in the same order of the topics that we covered. Okay, the second thing we did was separable equations. And if you look at that, you have dy dx is xy cubed over the square root of 1 plus x squared. Yeah, that's separable. Okay? And let's see what I did over there. Okay? Okay, the first part, the biggest part, getting the general solution, I gave 10 points for that. Let's go through that. How do we get the general solution? Okay. Oh, and also I saw many people, I mean, like I said, the first day, calculus is a prerequisite. And if you can't integrate 1 over y cubed, you know, it's really a shame because, you know, you have to review that stuff. I can't, you know, and then some people's integration was so bad. They integrated, they differentiated, instead of integrated, you know, what can I do? I mean, you shoot yourself in the foot when you do stuff like that. Okay, so problem number 2, let's just separate it. It's easy, you have it right in front of you, right? You can write this as the differential of y over y cubed. A lot of people got this integral wrong, which is, you know, what can I say? X over the square root of 1 plus x squared dx. Okay. Remember, I also said that I'm not going to give you any integral that's really hard to do. Some people put arctangent for here, they start making substitutions. Okay, okay, you can make substitutions if it's right, you'll get the right answer. But all these integrals that are put here on the exam, except maybe one integration by parts, you can do them in your head. I didn't want, again, to have people lose credit because they couldn't do some, you know, intricate integral. Okay, so that's that guy. Okay, that's the integral of y to the minus 3 dy, and it's just, you have y to the minus 2, and obviously in the minus a half in front, right? And just pause for a second, differentiate that thing. The minus 2 and the minus half cancel, you get y to the minus 3, right? This integral over here, okay, is just the square root of 1 plus x squared. Or maybe I should write as x squared plus 1 to the 1 half, make it a little easier to see. X squared plus 1 to the 1 half. If you differentiate that, what do you do by the power rule? You get 1 half, that stuff to the minus 1 half times 2x. That's exactly that. Okay? Nothing really hard about that, plus an arbitrary constant. Okay? So, if you got to that point, okay, one line, okay, you got 10 points. 10 points just for the general solution. Okay. Okay. Now, we have to go find the constant of integration. That's going to be 2 points, because that's just a plug-in. And again, if you got this wrong, maybe you forgot the half factor or something like that, but you got the C right, you got full credit for that. Okay, it's only 2 points, so now we plug in the values. What's the initial value over here? Y of 0 is 1, right? So when x equals 0, y is equal to 1. I go in here, I plug in y equals 1, I get minus a half equals, okay, x is equal to 0, that becomes 1 plus c. Therefore, c equals minus 3 halves. Right? Okay, and that's 2 points. Okay. Next thing you want to do is plug everything in and solve for y. Okay? This part, the last part, is 8 points because it's a bit of work. Okay? Let's go back over here. So we get minus 1, 2 half y to the minus 2 equals the square root of x squared plus 1, right? and the c is negative 3/2. Okay. Let me multiply through by negative 2. I get y to the minus 2 power equals negative 2, the square root of x squared plus 1 plus 3. Okay? Okay, then finally we take the reciprocal and solve for y. You'll find out that y is equal to 1 over the square root of 3 minus 2 radical 1 plus x squared. Right? Okay. So what's the second part? We can see basically we got a radical over there, and we're going to make sure that the argument is positive. Okay, and again, I try to give partial credit, at least if there was something that made sense, but I saw people just writing down stuff that I couldn't see any reason even for it. Okay, now the square root of 1 plus x squared, you're okay, right? That's never going to go negative, right, because x is real. So the only thing you have to worry about is the thing under the radical over here, right? That has to be positive. So therefore, we need 3 minus 2 radical 1 plus x squared has to be positive. And it can't be equal to 0 either. Notice I said greater 0, not greater or equal to 0. Oh, you think what a lot of people did is they looked at the root of this thing and then they excluded that point. You got partial credit for that, because at least it recognizes that you don't divide by 0. But what you have to realize is not only can't you divide by 0, but the thing under the radical has to be positive. Okay. 3 minus 2 is greater than 0. Okay, let's bring this to the other side and square. We get 9 is greater than 4 parentheses 1 plus x squared. Right? Or x squared plus 1 is less than 9/4. Which says that x squared is less than 9/4, take away 4/4 is 5/4. Okay? And then finally, you find that the absolute value of x has to be less than the square root of 5/2. That's the domain. Okay? So that was worth 8 points. Okay? Again, the most important thing here, basically, learn from your mistakes. Okay? Any questions on that last part? Okay. Yeah. What? Oh, yeah, sure, yeah. Sorry. Yeah. Last name? This one right here? First one. Okay, thank you. This is you? No. Okay. So that's problem number 2. Let's go to problem number 3. Again, just think of the topics we did. So far we've covered autonomous, separable, linear. Right? Linear first order. And remember how I said in class that a common mistake that people make is they don't put it in the canonical form. Remember with the formula for the integrating factor, you have to have dy dx plus p of xy, okay? And even if you forgot that, if you followed my suggestion of basically, after you get the integrating factor to check it, you would have seen you made a mistake, okay? So let's go to problem number 3 now. Okay. So you have the original thing in front of you. I'm not gonna rewrite it. Okay. So it's initial value problem. Okay. So we got to put it in the standard form, right? Divide by x, you get dy dx plus x plus 1 over x times y is equal to 1. Right? Okay. And I know I had some people who screwed up the division. I mean, I was disappointed over here. All right? That's 1 plus 1 over x times y is equal to 1. Okay. Okay, let's solve that. The first thing what do? You got to get your integrating factor. Okay? So, if you want to call this p of x, again, right? The integrating factor, call it IF, right, is the integral of the exponential, right? Exponential of the integral, sorry. It's just the exponential of the integral of p of x dx. So we got the exponential of, okay, what's the integral of p of x? Nothing could be simpler. The integral of 1 is x plus the natural log of x. Okay, and then we've done plenty of these in class, and I was emphasizing all the time that when you have these things, you got to know your laws of logs. And I have a lot of people who got the integrated factor correct, but they left it as e to the x plus log x. And then when it comes to the rest of the problem, it becomes intractable. Okay, what is that? That's e to the x times e to the log x, but e to the log x is x, you get x e to the x. That's the integrating factor. Okay, so how much credit for that? 5 points for the integrating factor. Okay, if you got to this point. Yes, that's 5 points. Okay, now what do? Right? We just multiply the differential equation through by the integrating factor, right? Which is x e dx. So I have x e dx times dy dx plus, just be careful now, okay, I get e dx over there, right? Well, by x times that is x plus 1 times y is x e dx. Okay? And this is where, remember I said this in class many times, this is where you can catch yourself if you made a mistake. Some people just assumed, oh yeah, I know it's going to be d by the x great factor times y, and they didn't check. And you would have, if you checked it, you would have seen you made an error. So what should happen is if we do things correctly, there should be d by dx of the integrating factor times y. And let's just pause and do that. If you do the product rule, you get x e dx times y prime, and then y times the derivative of x e dx, which is exactly e dx x plus 1. See, so if you forgot to divide through by x over here, and you made your p of x, I guess, x plus 1, you would have caught yourself over here, because it would have not have been the right form. Okay? So that equals x e dx. Okay. And then I'm going to give you 10 points for the general solution of this thing. Okay, so now we just have to integrate, right? So that says that x e to the x times y is the integral of x e dx dx. And most people got this. I mean, even if you just wrote it down, I didn't care. I didn't take off if you just memorized it or something, but you didn't have to. We did this one in class.